welcome back to class. This is a continuation of the course we have. This is a continuation of the topic we have been looking at, sort, and we have been looking at complex sort, where we look at multiplication and division of sort. But in this tutorial class, we are going to specialize on division, and under this division, where we have fraction, we have what we call rationalization of sort. And when do we rationalize sort? When we have square root at the denominator of sorts, of the fractional sort, we simply rationalize such sort. And how do we rationalize? We therefore multiply both the numerator and the denominator with the conjugate of the denominator. I have explained the concept of the conjugate of the denominator, the concept of conjugate of a sort in our previous class. Now, in this class, we are going to be applying and employing the principles that we learned when we were looking at the conjugates of sort. Now, on the board, we are asked to simplify 10 root 2. Of course, this is very simple. You may not have this as a question in an exam, but it will be attached to other sorts, right? But let's start from here. Then we advance to other higher calculation, right? Now, at this point, you will see that from this question number 1a, we have 10 over root 2. Like I said, in mathematics, it is not accepted that you leave your answer having a square root at the denominator or irrational number at the denominator. It is not accepted. So anytime you have a square root at the denominator, what you simply do is to rationalize. And how do you rationalize? You multiply both the numerator and the denominator by the conjugate of the denominator. But in this case now, we really don't need to use the conjugate of the denominator because we only have 1/10 at the denominator, right? So there is no plus sign here or minus sign that we are going to change respectively. Now, so this is going to be root 10 over root 2 times. Now the denominator is root 2, so we multiply the numerator by root 2 over root 2. This is just the process of rationalization. You now multiply the numerator and the denominator by what? The conjugate of the denominator. As simple as this. It's as simple as this. So what do we do, guys? We simply now multiply 10 times root 2, guys. We are going to have 10 root 2. And root 2 times root 2, we are going to have 2, guys. I'm not going to be wasting your time. We know in one of the theory that root 2 times root 2 is equal to 2. Is that correct? Yes. One of the theories we stated earlier in part 1 of this video or in this tutorial class, we stated that root a times root a is a. That means root 3 times root 3 is 3, and root 10 times root 10 is 10. Now root million times root million is million. Root 100 times root 100 is 100. The same thing it is. So root u times root u again is u. That's exactly what we have here. Now, the next thing we are quickly going to do is to see whether 2 can go into 10. Of course, these 2 cannot go into this because a number without square root cannot divide a number inside square root. They don't have anything in common. So it's only a number without square root that can divide number without square root, and number with square root that can multiply or divide numbers with square root. So these 2 cannot, we can't consider these 2 dividing this square root. No, we can only consider these 2 and this 10 because they are numbers that are not included in square root. Are we there? So 2 can go into 10 to have given us what? 5 root 2. This is the answer. 2 into 10 is 5. This is the answer to this. Then B, we had that 6 over 5 root 3 is equal to 6 over 5 root 3 times now. At the denominator here, we have root 3 as the sort there. This 5 is a constant, right? So we are going to be multiplying both the numerator and the denominator with what, guys? With root 3, not 5 root 3. Alright? But you can decide to use 5 root 3 because the 5 will still cancel out 5. But we are focusing only on the roots. Okay? So we are simply going to say root 3 over root 3. So guys, even though you said 5 root 3 over 5 root 3, 5 will still cancel 5, so we don't really need that. All we just need here is the root 3. So 6 times root 3, guys, we are going to have 6 root 3. And now this is this 5 times root 3 times root 3, guys, is 3. Yes. Root 3 times root 3 is 3. Just still using root a times root a is equal to a. You must be conscious of this rule when you are dealing with rationalization. This is the major or the vital rule and the sum of perfect squares that we'll be using when we come to the complex aspect of rationalization of sorts. Okay, so at this point now, root 3 times root 3 is 3. And we know that finally this will have given us 6 root 3, and 3 times this guy would have given us what? 15. Of course, 5, 6 and 15 have something in common. I have explained earlier that root 3 have nothing to do with all these ones now, right? So it is 6 and 15 that you can consider whether they have a common factor. Now, of course, 6 and 15 have common factor. Yes, 6 and 15 have common factor. And what's the common factor? 3. So 3 into 15, 3 into 6 is 2 root 3. And 3 into this is 5. That is the answer. This is the answer to this particular question. So this is the simple aspect of rationalization. Also, we have question number 2 on the board. Now, in this question number 2, don't forget we are dealing with what? Rationalization of sort. Now, at this point, what do we do here? It's the same thing we are going to do. We put down our solution, then have root 5 plus have root 2. Now, at this point, we have root 2 plus root 5 all over root 10. And now, at the denominator, please, in this case, now, at this point, all we simply do now is to have that this is equal to 2 root 2 plus root 5 in bracket over root 10. We just repeated the question times root 10 over root 10. It's as simple as this, guys. It's as simple as this. All you just use to multiply both the numerator and the denominator is the square root at the denominator, the root at the denominator. That's what you use to rationalize. Now, at this point, we know that root 10 times root 2 would have given us what? Root 20. Don't forget, root 2 times root 10, they can multiply themselves. So you now just have 2 times 10. That will give us 20. So everything inside square root plus 10. This times this guy would have given us what? Root 50. So root 5 times root 10 will give us root 50. All over root 10 times root 10 is 10, guys. Still using this theory, root 8 times root 8 is 8. So root 10 times root 10 is 10. Or another person says, okay, let me put root 100. And what is the root of 100? Is 10. Hope you get that clear, yes. You can say to multiply 10 times 10, which will have given you root of 100. What is the root of 100? Is 10, guys. So there's no need to waste much of your time by doing that. So always apply this rule, and this will have given us 10. But now the next thing we do, we cannot possibly leave this at this point. Why? Because this source can be reduced down to a simpler form. And how do we reduce that? At this point, guys, this will have given us 4 times 5. Hope you remember this. Then plus 50 will be what? 25 times 2. 2 factors for which one must be a perfect square. This is it. Then the next thing we do is that this guy will have given us what? 2 root 5. The square root of 4 is 2. Then plus the square root of 5 is 5 root 2. All over 10. Then finally, you can leave your answer like this when you are not dealing with OBJ. But for OBJ students, you may check out your options and see that none of the option is exactly this. Then in that case, all you need to do is to share the denominator for the two numerators. Since you have 2 terms at the numerator to one denominator, you can possibly share the denominator for those 2 terms at the numerator. What I mean is this will have been 10 root 5 over 10 plus 5 root 2 over 10. It is possible to have this like this. Then finally, what is common between this and this is 2. And this will give us root 5 over 5 plus what is common between this and this is 2. And we have 5 into itself is 5, and 5 into 10 is 2 root 2 over 2. This is the least answer to this very question. Now, there is no big difference between the question and the answer, but the difference here is that there should not be square root at the denominator. So you can solve it and find out that even the answer you have is more, it looks more complex than the question you are given. It doesn't mean you are wrong, okay? So assuming I stopped here, now what I have here is more complex than this. It doesn't mean that I'm wrong. But what I am interested in is that there should not be square root at the denominator. Hope that is clear. Now let's head on to this aspect. This is a special case. If you have not been paying close attention, please, at this time now, at this particular point, you need to pay attention because this is the 8th that requires much focus and much intellectuality. All right, there are multiple technicalities that we are going to be applying here. So please pay close attention so that you can get the full dose of what we will be releasing in this session of our class. Now, at this point, this is our solution, and I therefore have 3 over root 3 plus root 2. Guys, this is very simple. Now, what you do here, now you have at the denominator, you have root 3 plus root 2. You see now, there is a plus. So, when you have plus or minus in between two surds at the denominator, something happens when you are rationalizing. And what happened is simply to now multiply both the numerator and denominator by the conjugate of the roots at the denominator. And the conjugate of root 3 plus root 2 is root 3 minus root 2. So you now change this plus to a minus sign. That becomes the conjugate. So what do I mean by that? This would have given us 3 times root 3 minus root 2 all over root 3 plus root 2. This one now is this first one here. Then multiply by the conjugate would have given us root 3 minus root 2. It's as simple as this. Now guys, I gave us rule of the rule to this earlier on. Yes, this is rule where we have A over B plus root C. Is that correct? Yes, we have something like this earlier on today. Yeah, we have something like this, right? Now let's quickly look at what we have at this particular session of our class. Okay. Now at this point, guys, all we simply do here is to what? All we simply do at this point, guys, is to multiply out. Once you have rationalized, all you just need to do to rationalize, multiply the numerator by the conjugate of the denominator, which is just changing the signs that connect the source at the denominator, and multiply it with the numerator and the denominator. That's exactly what we have done now. The next thing is to multiply out. Now, how do we multiply out? 3 times root 3, we are going to have 3 root 3. Then minus 3 times root 2, we are going to have 3 root 2. You can decide to leave this or just leave it, but let's assume this is what we have. Now, at the denominator, okay, now we are interested at the denominator. This is 3 root 3 minus root 2 all over. Now, guys, at the denominator, we need to multiply out this expression. Now, there is an easy way to have this multiplied out. The easiest way to multiply this out is first times the first here, the last times the last. All right? This is the simple way to have it done. You just say root 3 times root 3, guys. Root 3 times root 3 will give us root 9, right? What is the square root of 9? 3. And understand by this rule that root 8 times root 8 is 8. So if I say root 3 times root 3, I'm going to have 3. So this will have given me 3. Then minus root 2 times root 2 is 2. This is the simple way to multiply out the conjugate of complex number. You don't need to do all the multiplication. There are other multiplications we have done here, but I just want us to make it very simple and short. Alright? So all you just need to do, first multiply the first, put that the answer, the last one multiply the last one, put that the answer. Alright, but understand that it will always be minus here. Yes, it will always be negative sign between them after you have multiplied out. So what next do we have? We are going to have 3 into root 3 minus root 2 all over what? 1. And anything divided by 1 is the same thing, guys. So we are going to have 3 root 3 minus root 2. This is the answer to this very question. The answer to this very question. So it is very, very easy to solve problems on rationalization very, very well. It's as simple as this. Like I said, there are multiple ways to expand this, but the easiest way to expand is to have the first in this bracket to multiply the first in the other bracket, then the last in this bracket to multiply the last at the other bracket. That's what you do, and that's how you get your denominator. Hope this video was helpful. Now, we are asked to simplify 2 over 2 root 3 minus root 7. Guys, without wasting much time, we already know that at the denominator we have square root. This is not different from question number 3 that we just solved. Alright? So all we simply do here is to rationalize. And to rationalize, we check whether we have plus or minus at the denominator. Now we have minus in between the source and the denominator, right? So what we do is to quickly find the conjugate of the denominator. And if this is minus here, the conjugate of 2 root 3 minus root 7 would have given us what? 2 root 3 plus root 7. That's the conjugate. So change minus to plus to have its conjugate. Now automatically this is going to give us 2 times 2 root 3 minus, alright, yeah, this is it, minus plus 7 all over 2 root 3 minus root 7 times the conjugate is 2 root 3 plus root 7. This is the conjugate of this minus here. Now we have positive. We have successfully multiplied the numerator and the denominator by the conjugate of the denominator. The next thing we do is to clear off the bracket, right? We need to clear off the bracket. Now, how do we clear off the bracket? We can simply say 2 times this guy and this times this guy, but we can leave the numerator first. We really do not have much. We do not have problem with the numerator, but it's the denominator that we have problem on. And like I explained earlier, the reason why we are rationalizing is for us to eliminate square root from the denominator. Are you there? Yes. That's the reason for rationalization, to clear up or remove roots from the denominator. So now I have this root 4, root 3 plus root 7 all over. Like I explained here, all you just need to do is this times this and this times this. First value in the first bracket times the first value in the second bracket. So that would have given us root 3 times 2 root 3, guys. 2 times 2 is 4. Root 3 times root 3 is root 9. And we know that root 9 is 3, so we're going to have 4 times 3. And this would have given us what? 12. Hope this is gotten here. So root 3. So this automatically would have given us, some people can decide to put it as, okay now. So we have 12. Then automatically we are going to have 12 minus. The next thing we do is to now multiply root 7 times root 7. Guys, like I said, multiply the first by the first and the last by the last. Ignore every other multiplication. Because when you try to expand in general, the two middle numbers are going to cancel out. Or the two middle figures values are going to cancel out. So we don't need to incorporate too many unnecessary steps. Right? Though I'm going to solve one problem where I will use that, then most of you will not like it at the end. Okay? Now, the next thing we are going to do is to now multiply the last value in the first bracket by the last value in the second bracket, which is root 7 times root 7. Guys, root 7 times root 7 would have given us 7, still using one of those roots, right? So this would have given us 7. It's as simple as this. The next thing we quickly do here is 12 minus 7. Guys, we are going to have 5. So this will give us this 2 root 3 plus 7. All over 5. So I can decide to rearrange this as 2 over 5 into 2 root 3 plus 7. I don't need to expand further than this. It's as simple as this. And many of us are very scared, too scared. We are so scared when we see rationalization. It's not something you should be scared of. It's just for you to know principles. So the principles are what we are just explaining. Now let's take a look at this. This one is very, very simple compared to question number 4. Question number 5 is very simple. Okay, now let's go. Now this is root 32 plus 6 over root 3. Guys, there is nothing to kill yourself about here. Now you see that this root here does not affect the two terms, right? This root 32 in its fractional form is root 32 over 1, right? So 32 in its fractional form is 32 over 1 plus 6 over root 3. So some people can decide to say, okay, let me find LCM. Guys, there is no need to find LCM here. Just use this rationalization to affect only this. Just solve this one individually. That's all you need. So what do I do here? I will solve this one individually and as well as solve this one individually. It's as simple as that. So it's as if you are connecting just a normal surd and what? A rational form surd together. Now, if I want to simplify this, I will find 16 times 2 are the factors of 32, whereby 1 will be a perfect square, right? Yes, 16 is a perfect square. Then plus 6 over root 3 times, at this case now the denominator here is root 3. So we have root 3 over root 3. There is no plus or minus, so there is no need to be changing sign, alright? Yes. The question do not come with plus or minus at the denominator, unlike this. Hope you can see it, yes. Now at this point, guys, what do we do? This is going to give us 8 times root 2. Right? Yes, I can decide to also put this one in bracket. 8 times root 2. Then plus 6 root 3 over now. Guys, root 3 times root 3 is 3. Still using one of those. So you see the importance of those rules. Please, if you do not get access, if you have not gotten access to those rules, please go back and watch the very introductory class of this video, which is the part 1 of this tutorial class. Go there, you can have access to the 10 rules that you use to solve problems under Surds, right? So root 3 times root 3 is 3. Now this will have given us 8 root 2 plus this goes into this, guys. We are going to have 2 root 3. This is the answer. So you can decide to factorize by having to know what is common between these two terms, right? Because I told you earlier on that for you to add 2 surds together, they must have something in common, right? Otherwise, you leave it like that. Now, if I have to add this and this together now, or move any step further, I will have to check whether this first term and this second term have something in common. Of course, they have something in common because the number outside the square root here is 8, and the one outside the square root here is 2, and 2 and 8 have something in common. 2 is a factor of 8. Therefore, 2 into 8, so I'm going to factorize it. Bring out 2, 2 is common. 2 into 8 would have given us 4 root 2, nothing happened to the root, plus 2 into 2 is 1, then I have root 3. This is the answer to this question. Don't forget, we are using the wise master's approach. Alright? Yes, this is wise master's approach. Don't forget, knowledge is light. Now, let's look at question number 6. We are asked to simplify. Now, in question number 6, we are asked to simplify 2 plus root 3 over 7 minus root 5. Guys, this is very simple. So simple. What do we do here? All we simply do here is to what? Rationalize. And how do we rationalize? We come to the denominator. We see that at the denominator we have a negative sign there, right? That means we have to find the conjugate of the denominator to be able to rationalize. And why do we rationalize? Because we want to eliminate that square root at the denominator. We do not want square root to be present at the denominator. In fact, it is an error. It is highly prohibited to leave your answer having a square root at the denominator. Don't face the penalty, alright? Okay, now we are going to have 2 plus root 3 times, what is the conjugate of the denominator, guys? All you just need to do is to change this minus to plus. So we are going to have 7 plus root 5 over 7 minus root 5 all times 7 plus root 5. Guys, like I said, it is very simple to multiply out. Now, in this case, we have 2 brackets at the numerator, 2 brackets at the denominator. So we are going to multiply the numerator and the denominator. Now, in this case, now I will see how we can expand everything here. So in this case, what do we do? 2 will come and multiply 7. Now 2 times 7, guys, we are going to have 14 expansion. Right? Then these 2 also will come and multiply root 5. So 2 times root 5, guys, we are going to have 2 root 5. We are done using 2 to multiply this number. Then the next is to what? 3 will multiply the first number here and also multiply the last number here. So now, root 3 times 7, guys, we are going to have plus 7 root 3. And root 3 times root 5, we are going to have plus root 15. In as much as both root 3 and root 5, they are inside square root, you can multiply the figures and put them inside one square root. Hope that is taken. That's the difference between other multiplication we did and root 5 times root 3. All over. Now I want to do the same here. Now I want to do the same as here. I'm going to have, let's do the same multiplication here. 7 times 7 will give us 49. First number times first number. This is what you do. Then 7 times this guy, we are going to have plus 7 root 5. We are done using the first number here to multiply everything in the second bracket. Then the next thing we are going to do is to now use minus root 5 to multiply everything in the second bracket also. Now we are going to have minus root 5 times 7. We are going to have minus 7 root 5. And minus root 5 times minus root 5, guys, we are going to have minus 5. Don't forget, root 5 times root 5 is root 25. And root 25 is 5. So, hope you are good to go. Now, the next thing we quickly, at this point, when we look at the numerator, critically we will see that there is nothing to add. There is nothing to add. So what do? We just leave it like that. We're going to have 14 plus 2 root 5 plus 7 root 3 plus root 15. There is nothing to add here. We cannot add anything here. Then at the denominator, this guy will cancel this guy. Plus 7 root 5 minus 7 root 5 we cancel out because they are equal and opposite. Yes. And that's the reason why I said earlier on, anytime you want to multiply, always multiply first and the first here. Multiply the first number here by the first number in the other bracket, and also multiply the last by the other, and forget every other one. So this has proven to us now that these and these guys we cancel out. So what we have is the first product and the last product. Then we are going to have 49 minus 5. And finally, guys, this will give us 14 plus 2 root 5 plus 7 root 3 plus root 15. All over. When we remove 5 from these guys, we are going to have, guys, when you now remove 5 from 49, you have 44. Then finally, this can be written as 1 over 44 all into 14 plus 2 root 5 plus 7 root 3 plus root 15. This is the answer to this very question. Guys, love you. Thank you for watching this video. Subscribe if you have not done so. Hit the notification bell if you have not done so, so that we can always notify you anytime we release my content. See you guys in the